Welcome to this presentation of the BGAN Application Tester, or the BAT. The BAT is a tool for completing simple terminal tests of BGAN, Fleet Broadband and Swift Broadband terminals end-to-end, as well as doing application and solution testing. When you're ready to start up the BAT for the first time, you'll be asked to go through a small setup wizard. Here you can choose to load an existing profile, edit an existing profile, or create a new profile. I will create a new profile in this demo. First, you will be asked to connect to the physical layer software. This is already set up when you use the BAT hardware, so in this demo I will just skip this menu. Next, you will be asked to select your terminal type. For this demo, I will select a Class 6 and aeronautical terminal. Click Next. The next menu is Power and Attenuation. This menu is very important when you use a real terminal because you'll need to define the RF power levels. You can find guidance to set this up in our BAT user manual. In this demo, I will use a software version of a BGAN terminal, so I will not set any values in this menu at this point. I'll click Next. The next menu, you will be asked to set the approximate location of the terminal. It's very important that the location in the terminal and in the BAT are aligned. Right now our terminal thinks that we're somewhere around London, so I will set the pin here. Also, you can select different spot beam maps. You can select the standard constellation, the AlphaSat map, MIAS coverage, etc. For this demo, I will use the standard constellation. Click Next. And you will also be asked to select your access points. You have a variety of options. For this demo, I will use the BGAN Internet Gateway and commit. And finally, you can choose to save the configuration you have just made, so you can retrieve it at a later stage. I will not save this one, I'll just click Finish. Now you're ready to begin your actual testing, and you'll see the dashboard in the BAT. The dashboard is a summary of all the different menus. You can see here we have a map, we have some bearer information in the forward and return direction, we have data connection information and terminal information. As I said, the dashboard is a summary of the different menus, and I'll just go through them one by one. Firstly, the map. If we just zoom in, you can see here that you can see 3 regional beams that are lit up in green, and also you can see an active global beam. These beams are active in order to be ready if the terminal should start to move, so they're ready to hand over. Right now we cannot see any narrow beams. We'll be able to see that once we have established an active data connection. The next menu is the physical link. Here you can see the physical link between the BAT and the terminal. You have information here on the bearer types in the forward and return direction. If you highlight any of the bearers, you can see the detailed bearer info in the bottom. Next is the terminal menu. You can see the terminal up here in the top line. If you highlight it, you can see the detailed terminal information in the bottom of the page. The information includes things like the current status, the reported position, spot beams, etc. We do not currently have an active PDP context, as you can see here, so I will go to my laptop to establish that connection. In this demo, I establish a connection to a software version of a BGAN terminal, but it functions the exact same way as it would if you had a live physical terminal. So I connect, I go back to the BAT, and you can see now that I have a PDP context and an assigned IP address. If I go to the data menu, you can see again at the data connection up here, and you can see the detailed PDP context info in the bottom. What is interesting here especially is the byte count. The BAT provides a very accurate account of how many bytes is sent and received by the terminal from the minute it has had an active data connection. Also, you can see the active time of the data connection. The network meter here will provide a graphical depiction of the data received by the BAT. Right now I'm not generating any data. In your test scenario, you would start using your application and you could see how much data the application is actually generating. For this demo purpose, I will go to my virtual PC and start a browser in order to create some traffic. Now it's starting to load the page. I'll go back to my BAT and you can see that the data is starting to flow through the tool, and you can see the count here in the bottom and you can see the graphs. This information can be used to optimize your application for less data usage and hence less airtime charges. The next menu is the SMS menu. This menu will keep track of all SMSs sent and received by the terminal. You'll be able to see them up here in the history. You can see here if I write hello world, send as an SMS, you'll be able to see the log up here. And the same will go for an SMS sent by the terminal that will also be logged in this menu. The status menu here, that will allow you to follow your course of testing. This log will log all events that has happened during your testing and allows you to backtrack and see what have happened if you want to go back and see what actions you took and what implications it had. That will all be logged in this menu. Now I've presented all the basic menus you can see here on the left hand side. Now we'll switch over to talking about the more advanced menus, the change and interact scenarios. Firstly, the one we call load scenario. From the outset, the BAT is set up to function as if you're the only user in the network, meaning that you'll get all the available bandwidth. This is not a very typical scenario in real life, so we have made it possible to add traffic or other users to the network. We have made 3 different presets, a low, medium and high traffic scenario, just to give an idea of what other traffic can look like. For instance, if we select a medium traffic load, you can see here that we have set up some streaming, some random background traffic as well. Right now, this scenario applies to all beams. If we double click, you can see here that all beams are selected down here. You can edit this scenario as much as you want. You press edit, and for instance, if I only want to make the streaming connection apply to this particular beam, select it and press update, and you'll see up here that it's been customized. You can do the exact same thing with the others. You can also choose to add a new connection that you set up here in this menu. You can always go back to the original medium scenario, where you have this traffic applied to all beams. Setting up traffic will allow you to stress test your application to see how it responds to functioning in a very congested area, for instance. The next menu is access points. In this menu you can choose to add your own APN. This can be of great value if you have your own network that you want to apply your own backend. So you can set that up using this menu. The third menu in the change and interact scenarios is the RF configuration. I showed you this menu when we went through the setup wizard in the beginning. This is where you can set the RF loss when you use a real terminal. You can find instructions on how to do that in a BAT user manual. And since I'm using a software version of a BGAN terminal in this demo, I will not change anything in this menu. The last menu in the change and interact scenarios is network impairments. In this menu, you are allowed to set up a variety of network scenarios that you can do to further stress test your application or your terminal. For instance, if you're in a very congested area and you want to set up a streaming connection, but there is not enough bandwidth, what will happen in the live network is that your terminal will be rejected by the network because there is not enough resources. This scenario can be set up. You click OK, you run your application or terminal test again, and you see how your application or terminal responds to this specific scenario. With Inmarsat, we have defined a range of scenarios in this menu that does sometimes occur in a live network and that we allow you to test here. Tests like these are not possible to do on air, so this is a way to really stress test your application or terminal off air. The last thing I want to show you is a mobility test. If we go back to the map, you can see that we have a red track here. This is a virtual GPS track that we are feeding to the terminal to make it think that it's moving. The track takes us from London to Aalborg to Berlin and back again. What this test allows us to do is to test how an application or terminal responds to being moved between spot beams or between satellites. Another thing that can be combined with this mobility test is congestion testing. For instance, if you have set up a lot of congestion in this spot beam and not a lot of congestion in this spot beam, you can actually test how your application or terminal respond to being moved between beams with different traffic patterns. This is quite interesting in order to see that your application or terminal can handle switching between different traffic scenarios and also just the fact that it's moving between beams. Thank you for seeing this demo. If you have any questions, please feel free to contact us at any time. Thanks.